Well, this is nothing to write home about. Fair weather cumulus, very common in June in Texas. However, we do have some changes on the horizon, so we're not going to be stuck with this for much longer. Let's check out the surface map and see where there is weather. The current weather picture for June 5th shows things getting active out in the western U.S. And we see the development of a very strong heat low in Nevada through Arizona. And there you can see the gusty winds, the blast furnace conditions, 101 at Indian Springs. That's definitely up there. I think they're getting a bit of downslope effect from the Sierra Nevadas. And if we take a closer look at the surface map, this is from Aviation Weather Center. This is just kind of mix things up. You can see 101 degrees there in Vegas. Got 105 there at Needles. And I think about the hottest temperature that I'm seeing is probably that 105 there, and also at Gila Bend. And let's check out the temperature at Death Valley. Looks like about 112 as of 40 minutes ago. So it's kind of a cool day there. So what's causing all that hot weather? Well, it's being caused by the increased flow from the west due to the pressure falls in northern Nevada and Idaho, contrasting with the cool oceanic air mass along the coast. That's producing a very strong pressure gradient. That's given us those westerly winds. Up in the northwest, it looks like the center of the low is somewhere in eastern Oregon. Up to the north of there, cool, mild conditions. Dew point's a little bit higher, up in the 40s there. Then looking down in Texas, we have a pretty quiescent dry line there along the Cap Rock, and that extends to a triple point. Looks like just northeast of McCook. At this time, we don't have any SPC severe risks, so we've probably got capping and ridging holding out over that area. If I was expecting thunderstorms, I would be looking at that triple point. Probably one of the best stations is right here at Lexington, 89 over 67, also 93 over 65 there at Hill City. So normally that would be a really good area, so we're going to check that area out just in case the parameters are favorable for storm development. I would also look up that front there for a possibility of upslope storms. 55, that's certainly good enough for convection on the high plains. There's a look at the structure of the air mass. Looks like a low kind of defined right there west of Hill City, but the front is up to the north there, and I think our triple point is lurking kind of in that area right there. And the dry line, I think we can paint that out. It's going to give us something like this and put the most favorable air mass along the Nebraska-Kansas state line and just over the front to the north. So what's wrong? Well, let's check out some soundings. So I'm going to start out in the moist sector, like right there, and see what kind of air mass we have. And what I'm seeing here is a very high temperature dew point spread. See that? 60. In fact, when you mix the layer, you're looking at 50s dew points. And with a temperature of 92 there, that's going to give you a low relative humidity and high LCLs. You see that LCL up there? That's way up there, almost at 700 millibars, 2.5 kilometers. So that's going to shut down any potential for tornadoes. In fact, let's just verify this and look at all the different measures. This is good for this because we get to see all the measures of surface, mixed, forecast, and most unstable CAPE. And we can see it's pretty consistently between 2.0 and 2.5 kilometers. So, yeah, it's both moisture and the temperature dew point spread that's a problem. Also, well, there's a lot of warm air up there, so we do have some capping. You can see the convective inhibitions run from 50 up to 150, depending on how you sample that. And I would probably take this mixed layer method into account more. So I think we're probably over 100 for the convective inhibition. What else? Well, hodograph not forming much of a curve there. The anvil layer storm relative shear, that's actually pretty good. And we can see that on this diagram right here. That puts the storms into the classic end of the spectrum, assuming you can get supercells. And then the rest of the parameters, they look just marginally good for severe weather. So the kinematics are not too bad, not favoring tornadic rotation or anything like that. The thermodynamics, that's more of a problem. So now what we need to do is kind of poke around and see if that's representative. Let's go into this zone of 60s dew points. And the parcels there are a little better. Capes up and around 2,000 to 3,000. Squeaking out a little bit more curvature. That's bringing the SRHs up into the 100 range. Problem again, though, is your LCLs. And you can see here in that STP outlay there, 0.02. So that's going to be a very poor contribution to the tornado problem. And another factor is the shear itself is just weak, kind of a lazy flow, and we only hit 50 knots once we get above 30,000 feet. And there's just enough opposing flow to kind of give us the bulk shears that we need to be seeing. So this is definitely, kind of a marginal hodograph. Also decapes, let's look at that there. Oh, that's way up there, 1400, due to that dry layer above 800 millibars. So that means you're going to have a lot of outflowish storms generating cold pools. And that's always a problem, especially with your LCLs up like that. Okay, let's sample a little bit more. I always like to take a few samples. Yeah, that's kind of the same deal there. And I'm going to go north of the front into Nebraska up to the I-80 area. And we start losing the moisture up there. Hodographs, yeah, they're starting to stretch out. But still dry air aloft in the mid-levels. And that's given us our decapes, which are a little elevated. But you can see the downdraft temperatures, 56 there. So outflow storms still a problem. Let's see if we get any convection. And I haven't even looked at the satellite, so we'll just see what the model does. Nothing really. Not really breaking out the cap, just a higher base stuff coming out of Colorado there later in the afternoon. Passing over Burlington, coming out towards Goodland there and dying off just after sunset. So high resolution rapid refresh, not going for any convection. And we can see the cloud fields out on that area are just about nil. Just nothing, maybe a little patch up there north of North Platte. So I think today, yeah, we're going to be relying on this stuff out here to move closer to the moisture, maybe develop, and that's a common mode of development this time of year. And of course, those cells are back behind the dry line, so they're going to be kind of high-based. Now, if we had this front a little bit further south, that would spell out more potential for severe weather. That you would probably have some moisture feeding back behind the front. And you would see these cells out here along I-70 really going to town. But on a day like this, 40 dew points, that's not really enough to support much of in the way of severe weather. So let's see what the model run is literally telling us. 4 p.m. Central. See, it's developing some showers along the Front Range, south of Denver to the Palmer Divide, and those move eastward, reaching Lyman about 7 p.m. Central Time. Lyman is on Mountain Time. And then they move out towards the Kansas-Colorado border about 10 p.m., so this is pretty late. They look pretty good there for a while, 10, 11 p.m. Central, and then they die off around the Garden City area. So that's the high-resolution rapid refresh forecast. I do want to see what the WRF ARW is forecasting. Even though this is a morning run, sometimes this model just nails it. So let's see. Yeah, that's the current run, 5th at 12Z. And going forward into this evening, breaking out convection on the high plains, a little less than what we have, and nothing. So definitely looks like a quiet day. I just noticed down in Memphis, yep, down here, 4 p.m., MCS over northwest Arkansas, spreading into Memphis about 5 to 6 p.m., and then propagating south into northern Mississippi. And then we have this other wing heading out over Little Rock about 9 p.m. and making a beeline for Texarkana about midnight. Huh, that's interesting. Is that what's happening? Let's check it out. Well, not exactly. If we bring this back to noon, let me get this centered. Hang on. Well, if we bring this back to noon, we actually have thunderstorm formation over the Blytheville area, not down here. And we run that forward. That propagates south pretty much as the model says, but the details are not quite correct. So that first line, well, yeah, that spread south is indicated, but instead of forming here and moving down to Louisiana right now, it actually formed up here and then moved south. So this is kind of in between those two MCSs. And I don't see any indication that anything's going up in this area yet. But couple promising towers in this area. We could still form that western wing. Let's look at the high resolution rapid refresh, and what I'm going to do is actually, yeah, there's the high resolution rapid refresh. This is very important. Normally it starts you off with the current model, but I'm going to take this back to this morning. In fact, I'm going to go back to 12Z. Okay, this morning the high-resolution rapid refresh was expecting stuff developing south of Memphis around 1 p.m. and then propagating south. That's kind of what we have. And then it's got this northern stuff going up. Let's see, that comes together about 4 p.m. right there around the Boot Heel. Moves into Memphis about 7 p.m. and that propagates sort of southeast or southwest into the Little Rock area around 11 p.m. and then dying off around Monroe, Louisiana around 1 p.m. Okay, or 1 a.m. Okay, so this is what we should be seeing according to the 12Z high-resolution rapid refresh. See those storms there well southwest of Memphis. Yeah, that's... I would say the high-resolution rapid refresh did do better, but I'm not seeing that stuff up to the north yet. So let's bring that forward. I'm going to go up to 17Z and see what it went for. And yeah, it correctly was catching that stuff developing like it was at the time, propagating more to the southeast, and then other stuff went up. Okay, this is where we are right now. That looks fairly accurate. Are we going to get that convection up to the north? Let's see what it's doing. No. Well, actually, it reforms it to the south of Memphis around dusk. And that moves south-southwest towards Monroe, dying off about 1 a.m. And yeah, that's interesting. Now let's go up to the very latest, the 20Z high-resolution rapid refresh, and takes it mostly south. And then towards dusk, it looks like some of the stuff propagates into Arkansas and Louisiana. It's actually picked up that activity a little bit. So increased chances, looks like maybe around El Dorado, Arkansas, down to Monroe about midnight. And that propagates all the way to Texas before dying off. Now, what you have to ask yourself is that a trend? If you're at Shreveport, that might be an indication maybe you want to start raising the probability of precipitation overnight. That's one of the things I would be looking at there. And this has got the appearance of a meso high, so there's probably a cold pool gusting out. And that could factor into tomorrow's convection. Let's find that cold pool. We'll go to the severe weather, pull up that supercell composite because it shows up really well there. Even though we're not forecasting supercells or anything like that. Let's check it out. Yeah, see that right there? We catch that little whisker there about 8 p.m. That spreads westward. And we can see it tracking onto Shreveport about 1 a.m. See that right there? All the way around. That's the outflow. That's what you would want to include on your analysis chart overnight. And that gusts rapidly out westward, reaches Tyler about 2 a.m. and reaches Dallas actually about 5 a.m. So that's a potent little feature there. And we'll look for that on the morning satellite charts. Now, as that feature moves westward, it's moving into an environment that's more and more stable. Texas is more under the ridging. We've got probably a little bit of capping. We've got the cool temperatures around dawn. And because of that, instead of seeing an outflow boundary that's sharply defined, we're probably going to see more of a gravity wave. And that's just where you've got a line of upward motion kind of overlaid on top of the environmental features there. So as we start getting the atmosphere boiling in the morning hours, you could see development along that gravity waves as it propagates west. Another factor, though, is the models don't handle those gravity waves very well 12 to 18 hours out. So I would expect to see a lot of differences in the final model position. But we know to actually look for that somewhere in central or north Texas and in Oklahoma. So we'll be alert for that tomorrow morning. So yeah, there's a little bit more mesoscale detail than you would think. See there, 10Z, you would think that there's nothing going on, but deep in that little set of data, yeah, there is stuff afoot. And we do have Cristobal to think about. Tropical storm there, 35 knots with a pressure of 1,000 millibars, pretty high. So it's definitely a weak system right now. Forecast cone, not much change, bringing that all the way up into the New Orleans area. And it appears the models have converged on that as the solution. And then tracks up into western Arkansas. And let's contrast that with the European model. European model has been doing a fine job. Pretty similar track, bringing it up into the Lafayette area Sunday night. And doing the same thing as the GFS. So we've got good agreement with these models. Looks like a lot of flooding precipitation all the way from Louisiana, Mississippi up to Arkansas. Ozarks probably going to get hit pretty hard there. Get that terrain interaction and a whole lot of precipitable water going inland. But the one thing that I do notice is the models have backed off from that little lazy figure eight that it was doing yesterday and just carrying the system north up into the Great Lakes. And looks like it actually deepens a bit as it goes inland. That's interesting. I guess it's probably linked up a little bit with the upper patterns. and acting more like a baroclinic system. And just checking on the GFS. GFS is not going for that deepening until later on as it becomes more baroclinic. So it looks like the ECMWF definitely more aggressive with the system in the Great Lakes. But we will see. That's midweek, and we got some time before that happens. Okay, and that's about all I got for this evening. And just a reminder for our Patreon supporters, you will get access to private videos Sunday and Monday covering the landfall of Cristobal. So we'll go into detail on that storm. If you want to get in on that, there's our Patreon. As soon as you're in there, you will get access. Otherwise, for the rest of you, we will be back on Tuesday as usual. Anyway, have a great weekend, and we will see you next week. Bye-bye.